welcome everyone. And in this episode, we are going to talk about customizable data collection. And in research, having control over data collection settings is essential for achieving precise study-specific results and being able to optimize the measurement time. And the flexibility to customize settings, whether it's sampling frequency, measurement rate, sensors that you want to activate, allows researchers to align data collection with their exact study objectives, enhancing the quality and relevance of the data collected. And today we will look into this customizable data collection and why is it valuable in research and how adaptable devices like the new Fibion Flash offers research the flexibility they need to address a range of study requirements. And this is also important that you can use the same devices in different projects, and different research groups can use those same devices. And different studies require different data settings depending on what the study aims are. And for example, physical activity research, sedentary behavior research might use a low sampling frequency to capture general movements. So for example, if you use a thigh-worn device and it's normal daily life, the thigh is not moving that fast, so you can go with the quite low sampling frequency, and this enables you to measure for long durations for the battery life and also for the memory size. But then if you, for example, want to measure sport biomechanics, you want to measure the acceleration of the arm in baseball, for example, you really need high sampling frequencies to really capture the quick, precise link movements. Otherwise, you will cut kind of the top of the acceleration and the results will not be correct. And basically, there's a Nyquist theorem, and you should have the sampling frequency at least twice as high as the frequencies in the movement. So you need to double the frequency compared to the movement frequencies. And similarly, studies on heart rate variability may require a different set of parameters and specific sampling rates to capture accurate cardiovascular data and also like autonomic nervous system data. And for example, with our new Fibion Flash device, you can choose different sensors. So it has 9-axis motion sensor. So you can activate the accelerometer, you can activate also the gyroscope, and you can activate the magnetometer. And if you don't need all of those, you can leave some of them out, having a longer battery life. And you can also measure full ECG curve, so one lead ECG curve, and you can get also the heart rate variability data, and from those you can calculate also heart rate. And yeah, like mentioned, this adaptability makes it possible to configure the device based on each study's requirements, whether it is for physical activity, cardiovascular research, or more biomechanical applications. And if we look a little bit more for the ranges, so for the accelerometer, there is a range ±2 to ±16 for the measurement range. And many times people think that, yeah, you should take ±16. It can measure more larger range, but basically you should select the optimal, because there is a certain resolution in the data, and if you go for ±16 and you don't, the sensor doesn't experience like large accelerations, you will lose accuracy. So basically, for example, for sedentary behavior and physical activity studies, you probably want to use ±2 or ±4. There's not much high accelerations, and even if there would be sometimes a higher acceleration that it will be cut, that's probably not as important as as very accurate data on the lower accelerations. For example, when you want to detect the 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 orientation of the thigh, that you can distinguish between standing and sitting. So yeah, you can select it for different study needs, and sampling frequency can go from 12.5 up to 416. So if you think that you're measuring with 416, you will have 416 samples per second times 3. So you have over 1200 samples per second. So the memory will get full pretty fast, but you get really accurate. So this would be kind of short-term measurement of certain movements that you could measure. And in this case, you could put, for example, several sensors on the body and get the accelerations in each body part. And also the sampling frequencies are the same. You can select from 12.5 to 416 for the gyroscope, and the range is from plus minus 125 to 2000 dps decrease per second. And also for one channel ECG, you can go from 125 hertz to 512 hertz. So a lot of different settings to be selected, and with these options, it's a good fit for many different kind of projects. And if you have any questions, or you're interested on Fibion Flash, check our website fibion.com. And from there, you can book a call with me or Miriam, and we are glad to tell more and see if the solution could be good fit for your project. Thanks for listening, and have a brilliant day.